Hi, this is Richard from Ascend Education. Now today I'm going to be going over the Hungarian algorithm, which is part of networks and decision-related mathematics on your further exam. As you guys would know, the Hungarian algorithm is a very hand and manual method, which means that there are a lot of hand calculations, and it's a very long style of question. As a result, what I've developed is something called the Hungarian algorithm solver, which solves all your allocation problems in less than a minute in most cases. What I'm going to go through today is the standard method of completing the question, and then what you're going to do is compare it to the software. Now this question is generally on exam 1 and exam 2, so it's important that you know how to do this by hand, and you get used to the software that I've created for you. So, let's make a start. We have Kate, Lexi, May, and Asim entering a competition as a team. Now in this competition, the team must complete 4 tasks, W, X, Y, and Z, as quickly as possible. Now the table shows the time in minutes that each person would take to complete each of the 4 tasks. And if each team member is allocated 1 task only, what's the minimum time in which his team would complete the 4 tasks? Now, what we first need to do is rewrite the table as an allocation matrix, and then follow the steps in our Hungarian algorithm steps that you guys should have in your theory book. So let's make a start. Now, our first step is to rewrite the table as an allocation matrix. So it becomes 6, 3, 4, 6, 4, 3, 5, 5, 5, 7, 9, 6, 3, 2, 3, 2. Our first step is subtracting the minimum element of each row from each element of that row. In our first row, our minimum is 3. So it becomes 3, 0, 1, 3. In our second row, it is 3 again, so it becomes 1, 0, 2, 2. In our third row, our minimum is 5, so it becomes 0, 2, 4, 1. And in our last row, our minimum is 2, so it becomes 1, 0, 1, 0. Now what we need to do next is subtract the min element of each column from each element of that column. In our first column, our minimum is 0, so we don't need to do anything. In our second, it's still 0, so we don't need to do anything. In our third, it's 1, so it becomes 1, becomes 0, 1, 3, 0. And our last column is 0, so we don't need to do anything, so it becomes that, 0, 1, 3, 0. Now what we need to do is cover the number of zeros with the minimum number of lines, okay? And because of that, what we need to do is we need to draw the number of lines to get the minimum to cover the zeros. So our first line is going to cover the 3 zeros, the 2 zeros, and there's no other way that we can cover the last 2 zeros. So because the number of rows matches the number of lines, we have a minimum allocation. So our next step is constructing the bipartite graph. So task and person. And we have W, X, Y, and Z. And we have K, L, M, N. Where there's a 0 means that they can complete that task. So task W can be done by Lexi or May. Task X can only be done by Lexi. Task Y can only be done by Kate. And task Z can be done by Nasim, May, or Lexi. Right? Now, because of that, we just basically sort out to the ones that can be only allocated a specific task. So, task Y must be done by K. So let's write that out. Task Y must be done by K. Task X must be done by Lexi. Task W, because of that, must be done by May. And task Z must be done by Nasim. Now because of that, if we circle it, task Y must be done by K. Task X must be done by Lexi, so task X, Lexi. Task W must be done by May. And task Z must be done by Nasim. So our total time is equal to 5 plus 3 plus 4 plus 2, which is equal to 8 plus 6, which is equal to 14. Now we're going to pause it there. Now, as you guys can see, it took about 3 minutes and 10 seconds to complete that question, which is a fair bit of time on your exam. Now, what we can do, and what I'm going to show you, is something called the Hungarian algorithm solver. So it's right here. Now, I should put that up, and then I'll pull that up. Right, so the Hungarian algorithm solver can be found in my documents in the networks and decision-related mathematics folder of your CAS. Now, he has Hungarian algorithms for 4 task allocations and for 5 task allocations. In this case, we only have 4 task allocations, so we're going to need to go to page 1.2. And what we need to do is we just need to enter our matrix in here. And if you guys go down, it'll tell us our minimum time here, or our maximum time. This is just a function that I've created, but the maximum time is never going to be asked for. So let's start the timer and just enter in our values. So it becomes 6, 4, 5, 3. It becomes 3, 3, 7, 2. It becomes 4, 5, 9, 3. And that last one becomes 6, 5, 6, 2. If we go across, it tells us our minimum time in about 30 seconds. So as you guys can see, this software is much faster. And it also tells you the combination. If you guys go across, it'll tell us combination number 15. Now, combination number 15 refers to something in your theory book in the set of notes that I provided. As it states in the instructions, you do need this theory book to find the combination so that you can allocate people to the correct task. Now, if you do have any questions, you can shoot me an email at richard@ascendeducation.com.au.